So our goal is to be able to calculate the measures of variation. So variance, standard deviation, and range. Those are our three measures of variation. So in your opener, you may staple your opener to the notes today because we'll be referencing that opener with the basketball players throughout the notes, so have it handy. We found that the basketball teams had the same mean, median, and good. Therefore, we use different descriptors indicating the amount of variation, or spread in the data. Also called measures of variation. Also called measures of spread. So there's two that are you'll find more often than the rest, and their range and then sample standard deviation. But make note that both of these measures are sensitive to extreme values. Just like when we talked about the mean, median, and mode, the mean was susceptible to extreme, or was sensitive to extreme values, like when we had outliers, it really impacted the mean, but not so much the mode or the median. Our measures of variation are sensitive to extreme values as well. So number one is the range, and number two is the sample standard deviation. So looking back at the opener, the range for our basketball teams, we had team number 1 and team number 2. What was the range for team number 1? How do we find the range?
You have to subtract the biggest and the smallest number.
Subtract the biggest and the smallest, the max and the min. 6 is the range for team 1. How about team 2? Thanks. Nicely done. 17 inches. Quite the difference here. Now we're starting to see some of those differences in those two teams and the heights of the players. Pros for using the range would be that it indicates that there's a difference in the heights of the members of the two teams. There's a pro. The cons include there's only 2 pieces of information being utilized to calculate the range, and so it doesn't tell us about the data set as a whole. So then we have the sample standard deviation. The sample standard deviation is indicating the measures of variation by indicating how far on average the observations are from the mean. So for a data set with a large amount of variation, the observations will be on average. So like team 2, you kind of had a variety of heights, more of a variety from highest to lowest. 17 inches was the range. You would find the observations will be on average far from the mean versus team 1. The players' kind of heights were closer together, and they would be close to the mean. Got 4 steps for finding the standard deviation, the sample standard deviation. So for step 1, you find the difference or the deviation from the mean. So first you'd have to calculate the mean, which we already did on our opener. Alyssa, what was the mean? 75. Thanks, Alyssa.
Thank you, Alyssa.
You're welcome.
So 75 inches was the mean. And we're focusing in on team 1 here. So within step 1, we're going to write out in the chart, list out all of the different heights. So, Draven, what were the heights for team 1?
Inches.
Yes, please.
72, 73,
Thank you. And step 1 also includes that we would subtract. So we're going to do 72 minus 75, which is -3. 73 minus 75, which is -2. 76 minus 75, which is 1. 1 again, and then 3. Now in step 2, we're going to obtain a measure of the total deviation from the mean for all observations, meaning we're going to add these all up. What do you get when you add these all up?
0.
0. Not so helpful. So in order to avoid ending with a total of 0, which goes in this blank right here, we get 0. We're actually going to square the deviations. Square the deviations. So -3 squared. 9. Everyone today has gotten that. Awesome. Remember in your calculators, if you square -3, any negative number that you square, got to include the parentheses. Otherwise, you'll just end up with a negative number, which isn't ever going to happen when you square a number. So -2 squared. 1 squared. Good. 1 squared again, and then 3 squared. 9. And now we add those up. We find the total of our squared deviations.
24.
Thank you. Mental math. So we have the total. Step 3, we take an average of the squared deviations. It's a funky average, though. We're actually dividing by n minus 1. Usually we add them all up, right, and divide by how many there are. We're adding them all up and dividing by how many there are, minus 1. And I'll tell you why in just a minute. But first we're going to work that out. Divide by n minus 1 for a sample standard or sample variance. So this whole process, we're going to get a value that's known as the sample variance. It also has a symbol. We always have symbols, and that in math, I like to use symbols because then we can incorporate those into equations and do all sorts of crazy things. So to find s squared, we're simply finding the average. We already found the deviations, squared them, added them all up to get a total, and we're dividing by n, there's 5 players, minus 1.
Oh, I thought it would be 23.
Oh, okay, yeah, glad we clarified. So 24 divided by 4,
6.
thank you. And this is the interesting part. Our units are currently, since we squared everything, our units are in inches squared. We need to fix that, because we're talking about a measure of variation for a data set, and the data set units of measure are in inches. So we need to get back to inches. Board points for that. That was awesome. We're going to take the square root. So step 4, our s squared value we just calculated was 6. And to find s, and the letter s, sample standard deviation is just going to be the square root of the sample variance. Square root of 6, that's something you'll have to do in your calculator since 6 is not a perfect square. Round to the nearest thousandth, 3 decimal places. Yes. 2.4, I want 3 decimal, thank you. 2.449, and now we're back to inches since we took the square root. So this is an indicator, again, of how far away, on average, the heights of our basketball players would land in comparison to the mean. Here's our note. Some of you are the curious type, and you want to know, why are we dividing by n minus 1 and not n, like we normally do with the average? One of the main uses of the sample variance is to estimate the population variance. You'll recall when we did different types of sampling methods, and we would do sampling methods and make an inference on the whole population, because sometimes finding the information about the entire population is super time-consuming and costly. So a lot of times in statistics, we're finding out information about a sample and applying those results to the population. When we divide by just n, it tends to underestimate the population variance. So there's actually more variation going on than what it would indicate if we just divided by n. So division by n minus 1 in the sample variance tends to give the correct value of the population variance. The correct value. So you can see this formula up here. I kind of breezed by it for a minute, but I want to zoom in on that for a second. This is something that looks a lot crazier than it is. It can make you feel really smart when you understand the details that are happening here, because you just did everything that is represented in that formula to find the S, the standard deviation for the sample. You start in the parentheses, right? This x sub I minus x bar, x sub I, that subscript, is an index. It just means it changes each time. So with data point 1, that would mean x sub 1. X sub 2 would be data point 2. So that's what that sub I means. So this first step is you just subtract, right? That's what we did in the second column with our basketball team. What order of operations, right? Back to order of operations, 7th grade math. Then we would square that, right? We take the difference and then we square it. That's what we did where?
And also the thing.
Yep, third column. Okay, so we did parentheses, we squared it, and then this symbol right here. And we looked at that in 3.1. Summation. We take the sum, right? That's what you just did here. This was the sum. And then what? Divide by n minus 1. That was step 3. And step 4 was take the square root. So it's really not as complicated as it seems if you become more and more familiar with these different representations of S represents standard deviation, and all of them are listed, right? N is the sample size. If you forget, it's in that little box, okay? So there's your, we'll become more and more familiar with that formula. Zoom back. So steps to finding the sample standard deviation. We took 4 steps and we kind of jammed them into 3 steps. So step 1, calculate the sample mean. We did that in the opener, so that would be your first step. Step 2, construct a table to obtain the sum of the squared deviations. Right, that's what we ended up with by this box right here. And then step 3, apply the definition 3.6 to determine the sample standard deviation S. So definition 3.6 is this guy right here. Okay? So I want you to try and follow those steps for team 2 from the opener. So look back at the opener. Let's list those out real quick. First we'll label our columns. Column number 1, X, or X sub I, either one. We could call it X sub I because that's the index symbol. And then X sub I minus X bar. Right, that's where we just find the difference. And then we do our X sub I minus X bar squared. And in this final row is where we're finding the totals. Just to make sure everyone's on track, can someone tell me the values that'll go in this first column? 67. 84? And then we already calculated the X bar. What was it? X bar was 75, right? The mean. So take it from there.